so this podcast has to do with calculating sig figs, or whenever we use significant figures in calculations, what do we do? Alright, so throughout the year you guys have been asking me, where do we round? Well, here's where you know how to round, or where to round. So it's not just as easy as in your math class, your math teacher might say, round to the hundredths place, to 2 decimal places, to 3 decimal places, to 1 decimal place. In chemistry it's not that easy, and in physics it's not that easy. Significant figures tell us where to round, so it might be a different placeholder every time we do a calculation. Alright? So there's really two things. We can either add and subtract numbers, or we can multiply and divide numbers. And the rules for these two things are different. So if we are adding or subtracting, so add or subtract, really our answer has same place, or decimal place, has same place as the value with the fewer places. Alright, so answer has the same place as the value with the fewer places. And the and fewer get really mixed up right there. So, for example, let's say we had 54.26 grams, okay, and somebody weighed it on a certain scale that measured to the hundredths place. And someone else weighed something that was they weighed this on a different scale. They weighed it on one of the more expensive ones in the back corner of my room, and it was 4.0210 grams. Alright, so when we add these numbers, we're going to add these two things together. We're going to find 0, it's 1, 6 plus 2 is 8, 2 plus 0 is 2, 8, 5. Okay, so what this says is the answer has the same place as the value with fewer places. So notice this answer goes to 2 decimal places, and this value goes to 4 decimal places. So what you ask yourself is, which of these goes to fewer places? Well, the top one does. And how many places does it go to? It happens to go to 2. So our answer has to stop right there. So based on our answer, this 8 isn't going to stay in 8 because the 1 is going to round that 8 down, or it's going to stay in 8. If we added up two values and this was 0.2870, this would turn into 58.29 grams. Okay? So again, when we add and subtract, the answer has the same place as the value with fewer places. And the rationale for this is there is uncertainty right here. Whenever this was measured, either by us or by a machine, this was estimated. Okay? So if this was estimated, there's estimation in the hundredths place. So whenever we write this number out, if we write it to the 10,000ths place, it doesn't really matter how accurate these last two numbers were, because we weren't even sure of whether this 6 is right. Maybe it should have been a 5, maybe it should have been a 7. So if there's uncertainty here, it doesn't matter how accurate we are further down the road, because we're unsure starting in the hundredths place. Okay? So this final answer again would be 58.28 grams. Alright? Okay, so if we multiply and divide, and this is what we tend to do more often than not. So multiplication, division is the answer has same sig figs, or we'll say same number of sig figs as the value with the fewest sig figs. Again, bear with my writing, it is terrible. I'm trying to go fast. Sig figs. Alright. So again, I'm going to just listen as I read this off. The answer has the same number of sig figs as the value with the fewest number of sig figs. So we might add number right here. Alright, so this is going to look like this. And again, this is what we typically do whenever we use fence and rails. We're multiplying. If we do something like molarity equals moles over liters, we're dividing. So most of the time, you're going to be multiplying, dividing. The time that we add and subtract most often is whenever we add up molar masses. Okay? So if we had a problem that was, I don't know, we had measured 2 lengths, and we were going to get the area. So we measured 2.25 centimeters. And for whatever reason, I don't know why you would switch and use a different kind of ruler, but use a different kind of ruler. And your other ruler just measures it to the tenths place. So you say this is 3.0 centimeters. So when we put this in our calculator, we're going to get 6.75 centimeters squared. Okay? So now what we're going to do is we're going to add up how many sig figs does this first value have. Well, the 2 is significant, the 2 is significant, the 5 is significant. So this has 3 sig figs. If we go to this one, we have 3.0. The 3 is significant, and then our 0 is a trailing 0. So these, you have to remember, are significant if they're after a decimal. So this is after a decimal, so it is significant. So this has 2 significant figures. So when we multiply, we get a value. Your calculator is going to give you 6.75. But when we multiply and divide, our answer has the same number of sig figs as the value at the fewest. So 3.0 only has 2, so our answer can only have 2. So our answer is going to become 6.8 squared centimeters. Alright? Why is it an 8? Because this time our 5, even though we're not going to keep it, is going to round my 7 to an 8. So 5 rounds anything up, 4 and less, keep it, keep your same value, or don't round up. And that is it for calculating with significant figures. Again, adding is the fewest number of decimal places, and with multiplying and dividing is the fewest number of significant figures. Alright? So now you don't have to ask that question anymore. Where do we round? Count sig figs. Whichever one has the smallest number is where you round to.